So what is the rectifier? So first of all, what are the some equipments? Let's take some mobile charger. The best thing. This is the mobile, and this will be cable. No, data cable is what we see, and it will go here, and you get this mobile charger. Nowadays we are calling it as mobile charger here. Now, what this mobile charger contains? What is the source? This will be connected to source, no? This will be some socket will be there. Some socket will be there here. Now, what actually it is? So this is nothing but an AC supply, no? So how much here? It will be 230 volt, 240 volt, and 50 hertz frequency. So what is actually thing? Mobile needs how much? Mobile needs, it needs 5 volt. It needs 5 volt, and I think nowadays we have around some 200 milliampere. You can put it. This much of current. Let me put 100 milliampere. So it needs 5 volt, a current of 100 milliampere. But what is this? DC volt is near DC 5 volt and 100 milliampere. But what we have AC supply in that socket. No, AC current will be there, alternating current. But the mobile watt pen needs DC 5 volt. How much of this AC supply? 240 volt, 50 hertz. How this AC supply will be like this, alternating. You know, AC circuit. Go back to that. VRMS is 240. So definitely, what is the peak value? The peak value will be more than this 240 volt. But how much we needed? We don't need signal. Mobile doesn't need this signal. Mobile needs a constant signal. What is the type of signal? The mobile needs a signal of this kind, 5 volt. But what we have in our house available, 240 volt, that to AC signal. So what I should do? I should convert that AC signal to DC signal. Who will do that? The rectifier. So inside the mobile charger, what will be there? A rectifier. So if you have any old mobile chargers, that you just break open, you see so many things inside that which I'm going to show it here now. What is the basically rectifier? It will convert AC signal to DC signal. There's a basic property of the rectifier. So inside that, who is the main component? The diode. The diode itself is called as a rectifier. The diode rectifies the signal. Rectify, you see word rectify. Please rectify your mistakes to minimize negative marking in the exam. What do you mean by that rectify then? Something you should change things, no? So what this diode, the rectifier will do, will make some changes to AC signal so that we'll get a constant DC signal. There's a primary thing. No. So how do that? First we'll start with the half-wave rectifier. So what all this half-wave rectifier contains? First it contains the transformer. To 40 volt, 50 hertz. This is a AC signal, no? Which is available in our sockets in home. This is a step-down transformer. This is a diode, and this is a load circuit. This is a RL. This is a diode. This is a P-type, N-type. This is a basic circuit. So what all this mobile charger contains, basic term is the transformer, then we'll get a diode. Then what is this RL? RL is what? Your mobile. So where is the load? RL is your mobile. Because this called like a load. Load means one which will consume the power, DC power. Okay, how the working of this circuit will be? This is a half-wave rectifier. Half-wave rectifier. So there's a sine wave. So let's get into the working part of this. So during positive off cycle, I'll draw the circuit here. Let me draw it neatly. So during positive off cycle, during positive off cycle, this end will be positive. It'll be like this. Positive off cycle, V in or VAC, you can call this is positive. So this end will be positive, this will be positive, negative. So what will happen to diode? Diode will be forward biased and the current will flow and will get a required cycle. But look at the primary voltage, this number of turns BNP, this is secondary. So what this transform will do? So it will provide that it will step down the voltage here. Any formula. So this will be V primary. I think let me talk in terms of peak values. This VSM, no? Number of turns, secondary peak value VSM or VS naught. I'll write it, huh? Because that M again. Vs naught, this should be equal to Ns by Np into Vpo. So the ratio of turns, so if I make, suppose I want say around 10 volt AC signal, what is VPO? VPO will be available certain value, say 240 into root 2, there is the available value. So I want only 10 volts. So I'll adjust the value of Ns, Np in such a way that I'll get that AC signal 10 volt. That 10 volt AC signal will pass through a diode. During positive off cycle, will get forward biased and will get a current. This one. During negative off cycle, this end will be negative. This will be negative. This is positive. So negative, what happened? Negative terminal of secondary will be connected to P type of a diode. So what is the state of diode? Diode will be off. Off in the sense open circuit. No current will flow here. So during positive off cycle, the diode will conduct and the current will flow through the load. During negative off cycle, the diode will be off because it will be reverse bias off, no current flows here. Then if I check the signal here, how the signal response will be. Only say what is the role of diode? Diode is on or off, forward bias or reverse bias. That's the only thing is what you have to check for here. So there's a signal. There's a positive off cycle, negative off cycle, positive off cycle, negative. What is this? This is the secondary voltage, huh? V in. This VSO is also called as V in. Don't take this input voltage. This AC signal is not this one. I'll write it very clearly. 240 volt. This is not our input signal. The input signal for the rectifier will become this one here. This is being rectified here. First, the transformer will step down that one. So that Vin is what we are showing it here. Okay, no. What about the output of the diode? How it will be? So we'll get a signal. Positive off cycle will be rectified. During negative off cycle, the diode will be off. Then again, the negative off cycle off. Then we'll get it. This is VL, the drop across the resistor. Is it a DC signal? Yes, I'm making the current to flow in one direction. What do you mean by DC signal? Where you are making current to flow in one direction. That's the idea of DC, no? What is the DC? The current at all time will be directed in one direction. So shall I call this a DC? Yes, I should call it a DC only. But what is the type of DC we wanted? We wanted a DC signal of this kind, not like this, no? The DC signal which is of this kind. This is what required, no? But what we obtained? We obtained, okay, let's manage, no problem. We'll see how I can directly bring this one. This is my target. Huh? This is a target that has to be achieved. So okay, some 40% I'm able to make that one. No native off cycle. I eliminated. This is the thing. This called okay the half wave rectifier. Now what has to be done? Okay, let's do some calculation part. I want the DC value here. What is the average? The DC emitter DC. What is the VDC? Is nothing but V average. So we'll write it. VDC is nothing but V average. This is the output total. What is the average value of this? Go back to the AC circuits. I asked you to remember these things. They're going to help you a lot. What is the DC value for off cycle? What is this value? Shall we write VSO? Peak value, no? So how to calculate the average value of off cycle? This will be VDC, which is needed, VSO by pi. And what about the DC current? A current I will flow, no? So if you want this IDC, IDC should be equal to VDC by RL. Like this, we can calculate it. So VSO is what this by. How to calculate VSO depends upon ratio of that one. So they may ask you even the numericals of these kind. You have to be careful. Number of primary, secondary. Okay, then I'll slowly. So this is not that good, no? What we expected. So something. Let's go for modification. I'll modify this circuit. Modify this circuit means I will introduce two diodes. I'll come to later on because some more concepts are there. No. Full wave rectifier. I'll slide